Assalamu alaikum student. In previous video, we have seen the answer of this question, and now we are proceeding towards the next question. Define chiral carbon and plane polarized light. Explain optical isomers with example. So we are going to start this question. So in this question, first we have to write two definitions. Each definition is of 1 mark. So 1 mark for chiral carbon and 1 mark for plane polarized light. And 2 marks are for optical isomers and their example. And 1 mark for optical isomers, definition of the optical isomers, and one mark for example. Remember that in this case, examples would be given two because not because we will see in the answer. Then we can consider that why we are giving two structure. Okay, so what is chiral carbon? Chiral carbon is a carbon atom that is bonded with 4 different atoms or group. यहाँ पर आपको आंसर के साथ स्ट्रक्चर भी बनाना होगा डेफिनेशन को सपोर्ट के लिए. सो फॉर सपोर्टिंग वी हैव टू ड्रॉ द स्ट्रक्चर बट नॉट दिस स्ट्रक्चर. ये तो मैंने बॉल एंड सॉकेट मॉडल जो आपको समझाने के लिए शो किया है. बट आप कैसे इस स्ट्रक्चर को ड्रॉ करेंगे? आप सपोज करें कि दिस इज द कार्बन एटम और कार्बन के साथ यहाँ पर COOH ग्रुप है, कार्बोक्सिलिक ग्रुप है. एटम तो कार्बन है लेकिन ग्रुप कार्बोक्सिलिक है. और यहाँ पर आप ये कंसिडर कर लीजिए कि यहाँ पे ये अमाइन ग्रुप है और ये फ्रंट वाला जो एटम है इसको आप कंसिडर कर लीजिए कि ये मिथाइल ग्रुप है. इस स्ट्रक्चर को हम बेसिकली जो बनाते हैं दिस इज कॉल्ड द वेज स्ट्रक्चर. और वेज जो है इस तरह से ट्रायंगल फॉर्म में है. तो यहाँ पे हम इसको शो कर सकते हैं दिस इज CH3. और ये जो बैक पर हाइड्रोजन मौजूद है मैं यहाँ पे इसको हाइड्रोजन कंसिडर कर रहा हूँ. इसको इस तरह से दिस स्ट्रक्चर इज कॉल्ड हैच. तो अब आप नोट करें कि इस कार्बन दिस कार्बन एटम इसकी सराउंडिंग में जितने भी ग्रुप्स हैं वो चारों डिफरेंट हैं. We will not see the atom only, we will see the group. This whole group is, although carbon, this is carbon, but we will consider the whole group. So these are different groups. One group is this one group is this one, and one group is this one, and one group is this one. So this is the chiral carbon. Chiral center or the chiral carbon. Okay, so on examination paper, you don't need to draw this diagram, although it is correct, but you have to draw this one. And next definition is the plane polarized light. Normally, light comprises number of electrical and magnetic waves that vibrate in multiple planes. When this light passes through a polarizer, a type of prism that is called polarizer, the waves are restricted to only single plane. Means when they pass through the polarizer, then only those are allowed to pass which are in one plane. And that polarizer stops the other lights, other waves. That's why this is called plane polarized light. Or you can define the plane polarized light as a type of light where the vibrations of the electromagnetic waves are restricted to a single plane. Unlike ordinary light, which vibrates in all directions perpendicular to the direction of the propagation. So I prefer you to write this definition because this is in your syllabus, this is in your textbook. So this is the definition, and I have shown this diagram just for uh, making you clear about the plane polarized light. Otherwise, you don't need to draw in examination. Okay. So see, there is the beam of light that comprises number of planes. Only two planes they have shown, one and the second. So when the polarizer is a kind of prism that allows only one type of rays to pass through. So in only one plane of the rays that pass through. So all the rays which are in one plane on this plane they can pass and other have been stopped. So this is the polarized light. This part after passing from the prism, this light is the polarized light. And it has a very important role in organic chemistry, especially in sugar chemistry. Anyway, so now the next part of the question is the definition of optical isomers. What are optical isomers? See, optical isomers are the two compounds having the same molecular formula, means there is no difference in their molecular formula, and even the same structure. In modern chemistry, we should use the word connectivity. Anyway, so they should have the same structure, means they have connected to the same carbon atom, means the carbon of the same carbon of the chain. I will explain with the structure later on. Anyway, so but what is the difference? Difference is only their optical activity, means the rotation of plane polarized light. One rotate the plane polarized light counterclockwise and one in clockwise direction. So if the two optical isomer य- यहाँ तक आपकी डेफिनेशन कंप्लीट हो चुकी है, आपके पास दूसरा पार्ट लिखने की जरूरत नहीं क्योंकि ऑप्टिकल आइसोमर्स की कई काइंड्स हैं. नाउ as we know there are several kinds of optical isomers, but one of the kind is called enantiomers. So what are enantiomers? If the two optical isomers are mirror image to each other but not superimposable, then they are known as enantiomers. So there are two important conditions for two isomers to be enantiomers. One is they must be mirror image to each other, and second is that they are not superimposable. What is mean by superimposable? I will explain it. First, see the example. This is one of the isomer. These are the four different groups, and this is the mirror plane. And in the image, what you see, you will see. So if two isomers, if you place them together, and they look like the mirror image, actually it is not the mirror. I have drawn two different structures, but I just wanted to show that these are the mirror images, but they are not superposible. And what could be these structures? For example, as I have given you example in uh, chiral center, I will use the same example here. See, yes, this example. So on the top, red one is the COOH, green one is ammonia, not ammonia, amine, and this is the methyl group, and this is hydrogen. Actually, this is one of the amino acid that is alanine. Alanine. So now come to this example. Now this green one is amine. This is carbon atom. This is carboxylic group. This red one is carboxylic group, and it is in front of the plane. So we'll draw the wedge structure. and this is methyl, and H structure shows hydrogen. Now, how to draw this another one? You just draw the central carbon, that is the chiral carbon, and along this chiral carbon, you draw it as it is, CH, and amine was here. So in mirror image, it would be on back side, opposite side, and methyl is here, so it would be in front. Draw in wedge structure. You just practice for it. This is CH3, and this is the hydrogen. So these are the two isomers. These are two different compounds. Both are alanine because they have same connectivity. This is also alanine. But uh, this is called L-alanine, and this is called D-alanine. It's enough for your answer, but I'm going to explain you why does it is called the mirror images, and enantiomers are mirror images but not superimposable. So I will show it. Mirror images is clear in this diagram. These two are also mirror images, but what is mean by superposable, I will show in another window. Wait a minute. Okay, now see the two compounds which are on the top and two compounds which are below. Now see, these two are mirror images to each other. The top one and this one are mirror images to each other. These are the same compound that I've shown in PowerPoint slide. Now see, I'm trying to superimpose on this molecule. It cannot be superimposed. See, hydrogen is superposed, but these are on the other side. Okay, now I will try to rotate. Okay, maybe on rotation it becomes superposed. No, it is not superposable. See, red is here, green is here. If it was superposable, then red would be on the red and green would be on the green, white on the white and on the white, blue on the blue. But it is not the case. Now try another rotation. In any case, it is not possible. Now in this case, only the green is superposable, but not the whole molecule. So in any case, these are not superposable. So these are mirror images which are not superposable to each other. Now see, okay, now you can see here. So these are mirror images but not superposable. Now we will try these two. First of all, these are not mirror images, but I will try to rotate them even they are not mirror images. And if I try to superpose, so you can see that they are superposable. Red is with the red, green is with the green, and hydrogen is with the hydrogen, white is with white, blue is with blue. So these are blue, these are superposible. But with those are mirror images, they are not superposible. And similarly, if I want to show you that these two compounds are same because they are mirror images to each other. But if you see whether these are mirror images, these are the superposible to each other, not mirror images. These are mirror images. The top two are mirror images to each other, but they're not superposible. Now, I will try which one is superposible to this one. Now, I will try this, but if you will see, this is not the superposible. Not. It means these are two different compounds. Now I will try here. Now see, these are the superposible. So it means the compound, this one, and this one, these three are the same compound, but this one is the different compound. And this is the mirror image, and these are not superposible. So actually, in this window, I wanted to show you that what is mean by the superposibility or the superimpossibility. Actually, previously this term was used superimpossible, and even in our book, they have used the superimpossible word. But actually, in modern organic chemistry now, we use the word superposible. Okay, now come to the same window again. Okay, we were here. So we were discussing about the optical isomers, and these optical isomers are the two compounds having the same molecular formula and same connectivity but different optical activity. Different optical activity means rotation of plane polarized light. One can rotate the plane polarized light counterclockwise, another one in clockwise. Anyway, we will see. If the two optical isomers are mirror images to each other but not superimpossible, then they are known as enantiomers. So these two are enantiomers, and these two representation are also enantiomers. Now, those which rotate plane polarized light in a clockwise direction are known as dextrorotatory. And dextrorotatory means dextro means right because they rotate the plane polarized light clockwise. That's why they are called dextrorotatory. And it is represented by a small d or in bracket with the minus sign. While the capital D and capital L are something different. It shows the configuration, D and L configuration. This is called DL configuration. It is something else. But in our book, they have used the word, use capital letter D and L for dextrorotatory and levorotatory. Sometimes it happens that which is represented by capital D, it is also a small d or, sorry, this is the not minus, this is plus, sorry. So dextrorotatory means clockwise. So the term dextrorotatory they have used correctly in our book, but small d is not correct. They have used the capital D. And sometime it happens that the capital D and small d are the same. But as this stereochemistry is not in detail in our syllabus, so we can ignore whether you use small d or capital D. So don't be confused about writing the answer that whether we should write the capital L or small l or capital D or small d. We can write either wise. So next, while those which rotate in anti-clockwise direction are known as levorotatory. So levo means left. So as they are anti-clockwise, so if it is one is known as right, so another one is known as left. So this is called the anti-clockwise or the counterclockwise rotation. and it is represented by the minus sign or the small l. And in our book, it is again, I'm telling the same thing. It is represented by capital L. So sometime it can be the same. So for example, in this case, this is the L-alanine, and right now this L-alanine, whether you write the capital L or small l, both are correct. And here it is D-alanine, and here the D-alanine, capital D or the small d is correct. So fortunately, they have given the example. So don't be confused about small d or capital D. You just follow the book and don't worry about it. Okay. So don't be confused about these terminologies. Okay. Now, I have explained uh, in detail the optical isomers, but what to write in examination? According to examination point, this definition is enough that you write the optical isomers are the compounds having the same molecular formula and same structure, but different optical activity. So up to here, the definition is enough. You don't need very much detailed definition. And then write these examples. Your answer is enough to get 4 marks. You don't need to write the definition of enantiomer because they have not asked. So that's all for this question. Inshallah, I will make another video for that will explain different types of isomerism in detail. But because here I am only explaining the question number 210, where optical isomers and their examples are asked. So that's enough answer. Okay, मिलते हैं फिर इंशाल्लाह किसी नेक्स्ट वीडियो के साथ.